Hello, I'm Aaron, and I'm here today with my colleague Narav, and today we're going to be talking about automating workflows for field data collection. We're going to do 4 separate demos, starting off with deploying apps and maps using Python, then following that up with a demonstration of using the command line to download attachments. Next, we're going to demonstrate a notebook that shows how to generate a PDF report. And then finally, we're going to wrap up with a quick demo and introduction to feature service webhooks with ArcGIS field maps.
Hi there, I'm Narav, and I'm going to be speaking a little bit today about how you can use the ArcGIS API for Python to speed up the deployment of your field apps to your workers. We're going to be focusing on 3 particular subjects today. We're going to talk about location tracking, about forms data collection, and about workforce coordination, and how you can use Python to improve all 3. Location tracking is a feature that enables organizations to capture the tracks of field staff, monitor where they are, and analyze where they've been. We've created the ArcGIS Apps Tracker module in the Python API in order to speed up setting up licenses, deploying track views, and enabling the location tracking service. Let's get started. So after importing our ArcGIS, we're going to check our location tracking status, and then if the status is disabled, we will enable it with a simple code snippet in order to be able to collect tracks from our workers. So now we've enabled it on our particular organization. Then we're going to move into assigning licenses. Licenses are required in order to be able to collect tracks from your mobile workers. So I've created a group now called workers, and we're going to get all the members out of those groups and then assign a license to each one in a simple for loop. So now let's put all of those same workers into a track view, which is going to allow us to easily visualize all of them together in ArcGIS Track Viewer. So I'm going to run this code snippet, which creates a track view. And oh, looks like we've already used that name, so we're going to need to change the name here. So let's go ahead and do that. Now we should have a track view with all 9 of our users within that group. So pretty easy way to get set up for, say, a larger location tracking event where you need to get everyone set up quickly. So now let's think about how we're going to deploy this on the mobile side. One of the great things about our technology is we've supported these app linking parameters. And one of our app linking parameters in particular is related to tracking. This is the reference context equal to track. Now we can run this code snippet and create a QR code, which our mobile worker can use in order to start tracking.
Now, let's move on to part 2. Smart forms are the new way to edit non-spatial information about GIS features in ArcGIS field maps. Smart forms allow for much more customization of the data collection experience compared to older workflows. While users will probably want to use the ArcGIS Field Maps web app, we have a new ArcGIS Mapping Forms module in order to help create bulk actions. So let's get started. First, I'm going to create a layer using an emergency shelters layer from Sample Server. So if we zoom in here, we can see that each of these shelters relates to a school. So I might want to create a custom form based on this layer, even though I do not own the layer. So first, I'm going to save this web map, and then I'm going to use the Forms module in order to set a title and add fields. So looking at my form, I can see I've added 2 fields, Facility ID and New Jurisdiction. If I go into my web app and go to my shelters form map, which is now created, I can go into Content, Shelters, Form, and oh, my form's not there yet. That's because we need to persist it to the backend. Currently, we only have a local form. So maybe let's make some more edits, and you'll see that the types of things I can do in the Python Forms module is very similar to the web app in that I can add groups, I can add fields, I've added a visibility expression here, and now that I've run form.update here, this should persist into the backend. Let's go back to the web app. We're going to refresh here. And we should see now our form with 2 fields and my single group with 2 more fields in it. So that's pretty exciting. So now let's go down. You might be thinking, what all can I do with the Forms module? So one of the best use cases that we've come up with is batch operations. Let's say that I wanted to copy a form between 2 different maps that have the same operational layer. I could create it again in the web app, or I could use Python. So first, let's create a second web app, which is going to be called Shelters Form Map 2. So we can go back into the web app now, and we see shelters form map 2 is there. So that's good, but it does not have a form yet. So let's persist the form from the first map to the second map. So just run that code, just going to copy over the form elements and expression infos. And now I'm going to navigate back to the web application. I am going to open up my form, and I'm going to see that that code actually found that shelters layer and persisted the exact same form. So if I had that same operational layer across different maps, I could easily persist forms and add new fields. So now let's go on to our third part. In part 3, we'll be talking about ArcGIS Workforce. ArcGIS Workforce is a mobile solution that uses the power of location-based decision-making for better workforce mobile coordination and teamwork. We can use the Workforce Python module in order to automate tasks. So we can automate project creation. As you see here, we've created a newer version of the project and an older version of the project, which correlate to different versions of the mobile application. So now if I go into the web application, and I can open up my new project or my old project. So in this instance, let's do the new project. I'm going to hit configure. I will go over to assignment types, and I'll see that there are no assignment types or users added. So these are requirements in order to have a workforce project. We could do it using the GUI, but in order to do it even faster, we can do it in Python. So I can run these simple code snippets, which will add workers from the same group that we were using before for Track Viewer, and let that run. And because we've already done a lot of workforce in the past, this is just going to be sort of brief intro. We've got previous demo sessions. Okay, so we've created our assignment types and our workers now. So let's go back to workforce. We can see that our assignment types, we'll probably need to refresh there, but we can see that all of our 10 users from that group have been added. And now if I reopen the project, I should be able to see my assignment type when I go to create my assignment. So being able to spin up these projects programmatically is a really powerful feature of the ArcGIS API for Python workforce module. So probably the best component of it is that you can then create assignments. So if you wanted to create an assignment, say through a scheduled task or through a serverless component, you would be able to do that using our Python module. So that assignment is created, and now if we navigate back to the notebook, we can see that there's just a ton of resources out there for using the ArcGIS API for Python. There's the API documentation, which gives you a lot of good information on sort of how to write these functions. If we go into the workforce module in particular, we've got some example code in there that should be really helpful. We've got prior scripts that we publish at our public scripts repositories. That's workforce scripts and tracker scripts. So hopefully this will give you a good start from which you can go create your own scripts and come up with your own ideas for helping with your workforce tracker and field maps use cases. So yeah, we've got one here that's pretty interesting. It's optimally creating and assigning work orders based on routes. So you might want to change the assignments based on routes. So this is just a brief introduction to deploying your field applications using Python. If you're interested in learning more, visit the API documentation or our scripts repositories, and feel free to open an issue or ask for a request there, as we'll be monitoring that and be willing to create new stuff for our customers. So in part 2, we'll be using one of our scripts at our new Esri Field Map scripts repo. So in this particular use case, we've got a bunch of workforce assignments, and a lot of these workforce assignments collected by our workforce have attachments to them. So, if I click on one of the assignments and I click on the attachment, you can see that, we've got the Apple logo here. So what if I wanted to download all of the attachments from these assignments? That should be a relatively easy task using Python. So if I go over to our Esri Field Map script repository, you see that this is a README for a download attachments from feature layer script. So by passing in the item ID or layer URL and then all of my auth requirements, I am going to be able to download all of the attachments to one place. And you can see we've got a lot of different stuff up there. We've got the notebook that I showed earlier that's called Field Apps Deployment Using Python. And then we've also got some other stuff, things that Aaron have showed or other use cases that we've heard from customers. So let's get started. We're gonna first clone this repository down. So that requires having the git command line. And so we've got all of the notebooks and scripts sort of downloaded, and now I'm going to use the instructions in order to be able to run the script. So I'm going to have to create my Conda environment. I'm going to paste that into my thing. And oh look, I'm not actually in the particular repository, so let me cd in there. And this is Mac OS, but it's relatively similar in Linux, and you could use like GitHub desktop or whatever you would want for Windows if you wanted that. So I'm going to activate field app scripts, and I see that download attachments is there. So let's learn from this particular example of sort of how to write this. So we need a username, password, and item ID. So with this command line operation, we should be able to run the script and download the attachments from that hosted feature layer locally. So I'm going to type out Python download attachments. I'm going to say, specify my username, specify my password, and then I'm going to get the item ID. For Workforce, it's actually helpful. The item ID is in the URL itself. So I'm going to copy that out and then paste it. And then we'll run that, and oh, look, I didn't pass org. So we've got some nice validation that your arguments are correct. So let me take that off screen, actually type in my password. So it should give me some output like authenticating, completed, and generally we try to include some sort of feedback so that what you're actually doing is correct. And one thing to note here is we didn't use all of our parameters. We only used the default ones. If you go through the README, you'll see that you can filter by where clauses. You can use the layer URL as opposed to the item ID. So you've got a lot of options there. So now I think everything is downloaded. If I go back into my scripts folder, this time in the GUI, we can see that there's an attachments folder where download is by default, and both of my attachments are now there. So this has just been a short look at one of our scripts. We've got a lot of stuff out there at field map scripts, tracker scripts, and workforce scripts. And we hope to continue providing new examples and use cases based on what we hear from our users. So yeah, thanks for listening, and hope you have a great Dev Summit.
One of the common questions that our team gets asked is, how do I generate a report for features that were collected out in the field? So today we're going to walk through how you can do this using the ArcGIS API for Python and some other open source libraries. In this example notebook here, I'm going to be working with a layer of trees that was collected, and some of these trees have attachments, such as photos that were taken, and we want to embed those photos, some statistics, a map, and various attribute information into our report. So to get started, let's sign in to ArcGIS Online. And I'm going to access my trees item and the first layer in there, which represents my trees. Next, I want to generate some summary statistics of my trees. I want to know for each type of tree the total number, the average height, and the average age. So we're going to run a group by statistics query here and get those three metrics. As mentioned before, some of these trees have photographs associated with them. So we're going to use the open source library called Pillow, which allows us to process images and, in this case, extract EXIF information. So the EXIF data contains latitude, longitude, time, and many other attributes. We're going to extract those three things and then embed them on top of the photograph in some yellow text. So we're going to go ahead and define this function, and we'll use it in a little bit. Down here, we actually kind of have this helper function called getLocationData. So this is actually going to extract the GPS coordinates and the time from our EXIF data. And because the data is stored in degrees, minutes, seconds, we have another helper function down here to turn that into decimal degrees. Let's define those two functions. And then one of the requirements in our report is to have a map for each tree. So we're going to use CartoPy and Matplotlib to accomplish this. Here, we're going to use the World Street Map tile service. We're going to basically create a map and then add a new feature to that map, and then we're going to export that map as a base64 encoded image. So we'll define that function. And now that we have all of our helper functions built, we can actually start generating our report. So the first thing we want to do is actually query all the features. So we're going to do that here on this first line, get all of our features. Then we're going to loop over each tree and create a map for that tree. Then we're going to download all of the JPEG images, and for each of those, we're going to process it to embed the latitude and longitude onto the image itself. So we'll go ahead and run this, and it's going to take a few seconds. Once that is complete, we're going to actually generate our report. So we're using a library called Jinja2. This is a templating library, and basically we provide an HTML file that is our template, and it's going to inject some variables into that template and then return the generated HTML. So we're passing in a title for our report, some statistics here, and then all of the trees that we want to render. So we can actually swipe over and look at the report here. So it's truly an HTML document. We have a title for it. We have a body down here. And then the first thing we want to show are some summary statistics. So we've generated a table here. So the top row kind of has the headers. So we have the tree name, the count, the average age, and the average height. And then for each of our statistics, so this is basically for each type of tree, we're going to add a row and then add a cell for the count, the average age, and the average height. Then we're going to insert a page break. And now we want to list out all the individual trees. So here we're going to loop over all of our features, and for each feature we're going to generate another table. And in this case we have attributes and values, and we're going to be injecting those different attribute values in our report here. If we scroll down a little bit, you can see we're injecting an image here. So in this case, we want to put our map for this tree into the report. So we'll do that here. And then finally, we have photos. So we want to embed each of the attachments that we collected and processed into our report. So again, we're injecting another base64 attachment here. So if we jump back to our code, we can run this, and it's going to return some generated HTML. And then finally, we're going to actually export that HTML to a PDF using the WheezyPrint library. And this is the output. We have page 1, trees. That's our title. We have a table of our summary statistics. And then we have, for each for each tree that was collected, we have the attributes for that tree, a map, and the photo with the embedded GPS data on it. One of the common requests that our team gets is around the ability to notify a manager or supervisor when a new feature has been collected. This can be accomplished today in ArcGIS Online using webhooks and a third-party tool called Integromat. I'm going to walk through a quick demo first on how this works, and then we'll walk through some steps on how you can build this yourself. So for example here, I have some hydrants and a hydrant inspection related table. I'm going to go ahead and add a new inspection report for this feature. And then once I submit this, I will actually get an email notifying me that this was submitted. So right now it's submitting the feature, and it has been uploaded to ArcGIS Online. So if we come over, this is my inbox here, and we have a custom filter set up to show us when we get new notifications from Integromat. And there you can see our email report with our new hydrant inspection. If I click to open this, you can see I'm provided a table with different attribute information in there. So let's switch over to Integromat and see how this actually happened. So what we're looking at here is the previous feature that was collected. You can see in the middle here, we have this pipeline that is processing the incoming webhook, and then there's two email connectors at the end which are sending emails. If we look on the left-hand side, we can actually see the entire workflow in the chronological order. So you can see first there's an incoming webhook. This webhook then triggers a bunch of operations to get a token, request some different URLs. Eventually we'll end up getting the JSON that contains the features that were changed or added in this case. Next, it kind of loops over the two different layers. So we have an inspection layer and we have the parent feature layer of the hydrants. And then for each of those layers, we're actually going to parse out the features that were collected. And then finally at the bottom, we're going to generate an HTML table. And then using the Microsoft 365 email module, we're going to send an email. So that's what happened when we ran this. So let's actually look at what this pipeline looks like. So I'm going to zoom in a little bit here. So the first step is there's an incoming webhook. So this is a post request coming from ArcGIS Online, and it contains a payload. And this payload looks like the type of event, the org that it's coming from, and the URL. We're going to parse that payload, generate some tokens so that we can authenticate to our server. Then we're going to eventually request this changes URL. So this changes URL actually contains the change set that we want to download. And this is an asynchronous API. So when we make this request, it's going to trigger a job, and then we're going to check the status of that job. So that's what we're doing here. We check the status, or we trigger the request, then we wait for the server. So we're going to wait 30 seconds or so for that job to complete, and then we're going to check the status and make sure that it completed. We're going to extract the payload from that status. So in this case, we have a result URL, which is actually a JSON file containing our changes. We're going to download that file, do a little bit of conversion here, and then parse the actual change set. So in our feature service, we have two layers. So we want to process those separately using the router. So we're going to process the hydrant layer, which is ID 0 on the top, and then process the inspection layer, which will be ID 1 on the bottom. So once we do that, let's look at the run here. So for example, you can see there's a JSON payload. It contains an ads array, and there's different attributes and the geometry here. We're going to parse that, and then for each of those features that was collected, we're going to generate an HTML string. And then finally, we're going to pass that string into the Microsoft 365 email module and email that. So at a high level, that's what we're doing. So now we're going to walk through how to configure a webhook in ArcGIS Online and integrate that with Integromat. So in Integromat, go up and click Create a New Scenario. There's many different modules to choose from. We are interested in the webhooks module right now. Select that and click Continue. Next, we want to configure the type of webhook. So we're using a custom webhook that will instantly receive data. So select that. Now we're presented with an option, so we could choose an existing webhook if we have one, or add a new one. In our case, we're going to add a new one and name it Hydrants. You can leave the default settings for now. Now you're presented with a link here, so we're going to copy that link. So this is the link that we want to post our payload to. Next, we're going to jump over to ArcGIS Online and configure our feature service to use that link. So this is a new feature layer that I've configured and published. I'm going to go to the Settings tab here. And one of the important things to note is that you need to enable change tracking in order to use webhooks. So I'm going to enable that setting on my feature service. Next, I'm going to go back to the Overview tab. I'm going to actually open up the URL to this feature service. So because I'm the owner of this feature service, I can go to the admin endpoint, and this will allow me to update the definition, add new things to my feature service, or in this case, configure webhooks. So if you scroll down, you can see there's a webhooks link here. We're going to click that, and there's different operations here. In our case, we want to create a new one, so we're going to click that. We can provide this a name. So in our case, maybe we call it new hydrants. Changes type. So there's a whole set of type of these. In our case, we want features created. You can leave the signature key blank, and we want to paste in the URL to that Integromat link. You can go ahead and click create. So now this created my webhook. You notice that there's a status here, and it is false. Active is false, and we want to change that. So we're going to edit this again and mark this true, and then persist those changes. So now that this webhook is configured, we want to continue to build out our webhook scenario in Integromat. But first, let's add this feature layer to a new map so that we can actually start testing it. Back in Integromat, let's select the webhook component here. And we want to actually be able to determine the data structure for this. So if we click redetermine data structure, it's now going to listen for the webhook. So we want to trigger this. So we come back to our map, we can edit, and let's add a new hydrant. Click close, and this will trigger the webhook, which will then be parsed by Integromat. One important thing to know is that in ArcGIS Online, the webhooks are not fired instantaneously. There's actually a delay between when the feature is edited and when the webhook is fired, and this is intentional. You can see it was successfully determined the payload. You click OK, and now you want to actually add the JSON module to parse that payload. So we can connect this here. And once you do that, you want to select the data structure that represents the webhook payload. So in my case, I've already predefined this, but you could look this up and add this as well. Once we do that, we need to tell it where the JSON is coming from. So in our case, it's coming from the payload of the webhook. Click OK. And then we don't have time in this demo to build out the entire scenario, so we're just going to go ahead and add the email client right now. So we're going to search for Microsoft 365 email and add that to our scenario, and we want to create and send a message. So we can wire that up just like this. I already have my account configured, but you can add yours as needed. You can give this a subject, or let's call it new hydrants. And for the body content, we're going to actually pass in the changes URL in this example. We're going to send this to myself. Click OK. And now our webhook should be ready to go at a basic level. I'm going to turn this on. So I can, well, first I need to save it. Then I can turn this on and select it to run immediately. So it's now activated. So now if I come back to my scenario here, let me add another hydrant feature. I'm going to go ahead and click here, and then now I should expect to see an email in my inbox as soon as this webhook fires. And there we have it. Click on this, and you can see the changes URL. So this just gets you started. We're actually going to have an entire blog post or series of blog posts to describe how you can build out more custom scenarios, and it'll lay out all the details that you saw in that first complete pipeline. So thank you for attending our session. Here's some additional resources you may be interested in. The product page, documentation, GeoNet, and then the GitHub repositories that Nirav was talking about earlier. So thank you very much and enjoy the rest of the Dev Summit.